Hello and welcome to another tutorial. In this tutorial, we're going to continue our discussions on the Java language basics. So far we looked at the creating variables and naming them, and rules and conventions for naming variables, fields, local variables, parameters of a method, etc. Now let's look at the second item here, creating primitive type variables in your program. Syntax to create and initialize primitive type variables. We already looked at this, but let's we already had a discussion about this, but let's look at it again. Creating primitive type variables in your program. You have already learned that objects store their state in fields, right? So we said that a class can have a state through the static fields. An instance of a class, which we call it an object of that type, of that class, right? A class defines a blueprint for a type, a user defined type. And then an object is an instance of that class, which means it can have its own data, and data means the state of an object, right? So any instance of a class stores its data into the fields. However, the Java programming language also uses the term variable as well, and we said that this means in C++, the common terminology is member variable, which means it's a variable that is not defined in the global scope of the program. It's a variable that is defined as the part of the scope of a class, right? So this section discusses this relationship plus variable naming rules and conventions, basic data types, and we said that Java allows primitive types, unlike other programming languages like Python. In Python, everything is an object, even a simple integer number is an object, but in Java we have primitive types, character strings and arrays, default values and literals. So if you look at the items here, the first one is primitive types. Initialize a variable with a default value, creating values with literals. We will talk about what literals are. Integer literals, floating point, character and string literals, using underscore characters in numeric literals. So let's start with primitive types. The Java programming language is statically typed. Statically typed, it's a static type. A static type means any variable in the source code, whenever you declare it, you have to give it a type. Declaration means you just tell the compiler what is the name of the variable, what's the variable that you're defining, and what the type is. And the reason the type is important is because then the compiler knows how much memory set aside for that variable. And the reason this becomes important, because when the compiler knows the exact value, it becomes much easier to do optimization, especially if you are operating on a large data set of let's say numbers that have the same type. For example, you're operating on 1000 numbers that have the same type integer. Then there are a lot of optimizations, because some of the CPUs have intrinsic instruction sets that can accelerate this kind of calculations if you're dealing with numbers or primitives of the same type. And it's called SIMD. For example, in Intel CPUs, we have SIMD, single instruction, multiple data sets, right? And that's about the vectorization capability of CPUs. And these are really in the hardware level, like CPU supports them in the same clock, in the same clock, which means the amount of time it takes to do one calculation per clock, which is about 1 nanosecond. You can do a vector instruction, which means now you can add up, for example, 4 integers. If you have a 32, if you have like for a vector, at the hardware level, if you have a register in the CPU that is capable of holding 4 integers, 4 32-bit integers, which is 128-bit. Nowadays we have AVX2 vectorization capabilities for 64-bit CPUs, which allows, for example, 512-bit wide registers. And that's awesome feature you have. So if the compiler knows what the exact type is, then it knows the size, how many bits is required, then it can more efficiently take advantage of the hardware architecture. And that's the job of JIT compiler in Java. In C++, we not only C++ is statically typed, but also it's statically compiled, which means it directly compiles to the machine code, machine instructions, right? Hardware instructions. In Java, the compiler compiles to the intermediate level, which is bytecode, and then the JIT compiler at runtime, it can compile to the optimized machine code and then cache it so that it can be used. But that only happens at runtime, right? So statically typed, which means that all variables must first be declared before they can be used. So we have a declaration, which you just say what the name is, what the type is, and then definition. Definition means now you have to initialize it, assign a value, right? So for example, if you use this statement, int gear equals 1, this is the first time you're defining or you're using this name and saying that it's this type, and we initialize it to this number 1. This is called definition, because not only you tell the compiler what the name is, what the size is, you also tell what the value is. If you just say int gear and then semicolon, that's allowed. You are declaring a variable, but it's not initialized. And then the compiler, based on what type of variable this is, if it's a field, the compiler or basically the JVM will initialize it at runtime to a default value. If a local variable, the compiler gives you an error if you try to use the local variable after you declare it and before you initialize it, right? This involves stating the variable's type and name, as you have already seen. Doing so tells your program that a field named gear exists, so you declared it. Holds numeric data, it's primitive type. So you tell the compiler what type it is, and has an initial value of 1, right? So you give it the value. So this variable has been fully defined and initialized. So not only what you tell the compiler that it holds numeric data, you also tell it at runtime what the size of this data is, 32-bit. Now the problem with size is that now if you want to hold a large integer that doesn't fit in a 32-bit integer, then you end up with overflow or underflow. Because remember, everything in Java, all the primitive types are signed. So integer is 32-bit, so it goes from -2 to the power of 32 over all the way to or -2 to the power 31, all the way to plus 2 to the power of 31 minus 1. I mean, you can Google to see what the ranges are. But then obviously, if you are initializing an integer with a number, which is called integer literal, you can type as many digits as you want, right? You can type 1000 digits here, and the compiler won't. In Java, it might complain. We can test that. But in general, you can end up with the underflow or overflow, which means that the value that you're assigning doesn't fit perfectly in a 32-bit integer. Then the compiler either refuses to compile, gives you a compilation error, or it silently compiles, or basically it compiles, it's silent. It might give you a warning about overflow or underflow. Usually C++ compilers do this kind of stuff. In Java, we can test to see what happens. A variable's data type determines the values it may contain, plus the operations that may be performed on it. Now, there are some promotion rules. For example, what happens if I add a variable of types integer to a variable of type double, for example, right? Because these are just zeros and ones in memory, but the way that the Java, or basically at runtime, these values, zeros and ones in memory, are interpreted all depend on what type it is, right? And in Java, whenever you assign a integer, for example, to a floating point, the integer is silently converted to a float, and then the result is also float. So there are some promotion rules in terms of mathematical operation between primitives. So you can Google it and look at them. We probably will end up looking at them in the rest of this tutorial. A variable's data type determines the values it may contain, plus the operations that may be performed on it. In addition to int, the Java programming language supports 7 other primitive data types. And again, it was a very good decision that they decided to allow the existence of primitive types, because remember, Java was supposed to be purely object-oriented programming. Anything had to be objects. But then wrapping primitives into classes, it's not a very efficient thing, especially if you want to do mathematical computations. A primitive type is predefined by the language and is named by a reserved keyword. So all these int, double, float, etc., these are keywords. So you cannot have a variable that has the same name as a keyword like int, etc. Primitive values do not share a state with other primitive values. What this means is that these are just stored as a raw binary in memory, right? A 32-bit binary. If you are familiar with the class references, for example, references not only hold the state, but the actual representation of the memory of a reference to an object has a little bit of headers to store some extra information about that object. But these are not objects, these are primitive types. So these are raw zeros and ones that map directly to the size of the size of the variable. Now, one thing that I like to point out, so let's create a new class. Let's call these primitives, and I want to have a main method here. One thing that I like to point out, you see, if I say int dot class, what does this return? So let's maybe assign this to something. Let's say class of some type. Class is int dot class. Now this is allowed, and this is very interesting. We said that int is a keyword, so and it refers so a keyword, you normally you shouldn't be able to use the dot operator on a keyword, right? Because keyword is part of the core language, right? It doesn't refer to any object or anything. But interestingly, you can call the dot on the dot on the int, and the only time that you can use the dot when you call the class. So you can basically use dot class on primitives, and this returns something called a class object. Now we can do a sysout on this class to maybe get some information about this, and it says it's int, it's raw int. Now we have also a wrapper integer class. So a class of class 2 is integer dot class, and this is obviously allowed. So dot class is allowed on any class type, any type that represents a class. And if obviously I can hit command and open the definition of integer, and you see that it has it defines a class, right? And then so what happens here is that we can do also a sysout on this class 2. It says it's a class, and it refers to where the class is on the class path, the fully qualified name Java lang integer. Now, so you see that integers are keywords, so primitive types are part of the keywords of the language, but you are allowed to call the dot class. And the reason they added this, so basically if you are familiar with the Java reflection, you know that dot class refers to a meta information that JVM at runtime saves in the meta space of the Java heap. So dot class basically represents meta information about that type. Whenever we say type, it means anything in object has a type, right? Anything in Java has a type. Even int is a keyword, but it's a type, right? You can say int a equals 2, which means this is a variable and this is something that defines the type. Or you can say integer a equals 2, right? And then we already know that this results in autoboxing, but that's not the point here. The point here is that any type, anything that defines the type, even primitives, has to have meta information, which is represented by the class object, right? And then basically, the way you get this class object, a class that represents the meta information of that type, even primitive type, you call the dot, you have to call the dot class on that type, even primitive. That's why calling the dot class on a primitive is allowed, because that returns that's the defined way of or that's the only way of getting the meta information of that type, even primitives. That's what I want. And the reason we have to do it because of the Java reflection. A Java reflection is basically if you want to call a method, for example, using reflection, and that method, for example, let's say the name is foo and it takes a primitive integer a, right? So usually what you do, you get basically a method class from Java lang reflect, right? A method class or method identifier, let's call it m, and then you get it, and then what happens here is that then you wanna call it or invoke it, but then you have to give it the description or the type of the parameters, because Java needs to know the type, right? The reason you have to specify the type because of method overloading. Maybe you have another method with the same name, but it takes, for example, 2 parameters, right? because Java allows method overloading. When you try to call a method reflectively, you have to tell it the type of parameters. And the question was, how do we specify the type of parameter? Should we just use int? And this is not allowed. So basically that's because the assumption was that every type has a meta class or a meta information. So you, instead of saying invoke this and the type is, for example, int, you say int.class. If you want to invoke the second one, you want to say that int.class, int.class. If the second parameter is a primitive double, you say double.class. So the .class operator, you can even use it on a primitive types, on a primitive type. And the point that I want to make here is that a primitive type is a keyword. Like integer is not a keyword, right? So the question is, can I have, for example, integer 2? This is allowed. Integer is not a keyword, right? This capital integer, but it can define a type if you use the full this class, right? So but it's allowed. Integer word, it's not a keyword, but int is a keyword, so you cannot say int. You cannot have a variable that has the name exactly equal to a keyword like int or int double, etc., right? So what this means is that, but then so primitive types differentiate from actual wrapper classes because these are keywords, but you are still allowed to call the dot class and get the meta information. That's just because of the Java reflection, which is more of an advanced topic, so I'm not going to go into more details. Now obviously this is not the case in other programming languages like C++. In C++ you obviously you have the same int, for example, keyword, but you can never call a class on it because at runtime there is no meta information associated with this keyword int, right? Because obviously C++ is statically compiled. There is no reflection allowed. You cannot, at runtime, you cannot inspect the types or do something. I mean, obviously they have been trying to come up with some sort of reflection framework for C++. I don't know what the progress on that, but the fact that statically compiled languages which directly compile to the machine code, they really don't allow this kind of runtime reflections. That's just because it's just machine code, right? You cannot save meta information, etc. So a primitive type is a keyword. Primitive values do not share a state with other primitives. The 8 primitive data types supported by Java programming language are byte. Byte is 8-bit. It's signed integer. It's a 2's complement integer. If you don't know what 2's complement is, you can just Google it. But 2's complement is a way of representing signed binaries. For example, -5, -10, this kind of stuff. Because binaries, zeros and ones, it's very intuitive to associate a sequence of zeros and ones to a positive number, right? It's base 2 number. Just the decimal numbers that we already use, like 10, this base 10, but we can also, any base 10 number can have also a base 2 number. But then the question is, how do we associate negative numbers in base 2, right? And they came up with this concept of 2's complement. It's the easiest way for computers to like represent binary numbers and especially do mathematic operations. And I believe on the hardware level, I guess CPUs already have support directly for 2's complement calculations. For example, adding a plus number to a negative number, etc. It has a minimum value of -128. So 8 bits, you go from -2 to the 7, which is -128, to a maximum value of 2 to the 7 minus 1, which is 127. Note that the reason we don't go to the 2 to the power of 8, which is 256, because the left bit of the 8-bit sequence is reserved for the sign. So you have to give up 1 bit to tell is it positive or negative, right? So you lose half the range that you already can use, right? Other languages like C++, they allow unsigned integers. So if you define an unsigned char, for example, in C++, we don't have the byte keyword, we have the char keyword, which represents 1 byte of data. And we know that C++ is based on UTF-8, 8-bit character encoding. That's why they decided instead of using byte, they use char. But you can still use char as a 8-bit integer, even for simple mathematical calculations. The byte data can be useful for saving memory in large arrays. Usually in these days, memory is not a problem. We can have servers that have terabytes of memory. Really, I mean, at this point, usually if you see a mathematical framework written in Java, you always see int and doubles, because int is the default integer, and then double is the default double, and we don't really care about the memory that much in these days, because RAM memory is very cheap. Obviously, if you really want to optimize your mathematical code, you have to think about cache lines, because it's not just about the memory at RAM, it's about being able to cache a large set of data, because that's the quickest way for the CPU to get the data and operate on them. Remember, CPUs are always data hungry, which means they like to be fed data. The problem is that they most of them, they're waiting for the data to arrive from RAM to CPU, because the speed of CPU, the speed at which the CPU can operate, is much faster than the speed at which you can retrieve data from RAM. That's why they came up with the concept of cache, very high speed and small sizes of memory that are inside the CPU. They're very close to the CPU, and they can retrieve some data, store them for later use. So if the cache size is limited, for example, let's say you have 1 terabyte of RAM, but your cache size is only 10 megabyte, then you need to think about what is the best data type that I want to use if I want to really optimize for the cache. So byte is the smallest integer. It's always signed. Every integer, every number, every primitive number in Java is signed, integer or float, double, etc. They can also be used in place of int, whether their limits help to clarify your code. The fact that a variable's range is limited can serve as a form of documentation. So I'm going to leave the rest of this tutorial for the next one. I hope you enjoyed this. Please stay tuned, and I'll see you in the next one.